For anyone who may have needed some help with the dot diagrams that we did the other day in class, um, here is just a step-by-step little video for us in order to do some dot diagrams. So, for example, if we start with something simple like HCl, the first step is to get the sum of the valence electrons. So 1 for hydrogen and 7 for chlorine, which means that we have 8 electrons to work with in our structure. Because there's only 2 atoms, we place them next to each other. And the next thing that we're going to do is try to determine how many bonds each atom should make. So one method that we like to use is the happy minus have. Happy, of course, meaning stable. And for hydrogen, its stable number is 2, stable with a duet, minus 1 valence electron means that it's going to make 1 bond. Chlorine stable number is 8, minus 7 valence electrons means that chlorine also makes 1 bond. So in order to make 1 bond, hydrogen puts 1 valence electron in, chlorine puts 1 valence electron in as well. Those two are shared. Hydrogen has used its valence electron. Chlorine has used one of its 7, so it has 6 left. If I show you also using just some description here, all of these electrons belong at least partially to chlorine. So now chlorine has 8 valence electrons around it, giving its octet. These two also count for hydrogen. So now hydrogen has its stable duet. Now, that's not the end of the dot diagram. Remember that when we are looking at these dot diagrams, if they are asymmetrical, we have to indicate polarity. This is a dipole, it is asymmetrical, so we can either point to the negative side and cross the positive side, or in a separate little diagram here, a different way to do it is if we have this HCl, the bonded electrons, remember, can become a line. 1 line for 2 bonded electrons. Higher electronegativity is the negative side. Remember, we use delta to represent the partial charge, and we can write delta negative on the negative side and delta plus on the positive side. So again, this molecule does have a dipole moment. The way that we indicate polarity is either with the arrow or with the deltas. If we wanted to draw the dot diagram for Cl2, again, we're going to take the sum of our valence electrons, Cl plus Cl, means that we have 14 electrons in our structure. We already said that Cl makes 1 bond. That means that each atom puts 1 electron into the sharing pool. That means that we've used 2 of our 14 electrons. 12 remaining get separated, 6 and 6. This molecule is symmetrical nonpolar, so we would say that it has no dipole moment or no net dipole moment. SO3, again, we would sum up and add up all the valence electrons, so 6 for the sulfur plus 3 6s for the oxygen, which is 18, which means that we have a total of 24 valence electrons to work with. Remember that our main rules are use the dots for the valence electrons you have and give the atoms stable octets or duet for hydrogen. Because there is a single sulfur and multiple oxygens, that means that the sulfur goes in the middle. I try and do my happy minus have, but what comes out is that oxygen should make 2 bonds and sulfur should make 2 bonds, and there's not really a way to make that work. So I'm going to just do this one by trial and error. And I'm going to say, well, sulfur has to bond with each oxygen. And in order for that to happen, they each have to put in at least 1 electron, right? That's 6 of my 24. That leaves me with 18. And if I put all 18, I'm just going to do this really quick here, that would satisfy the octets of 3 of the 4 atoms, but not all 4. When that happens, we try a double bond. So I have some room here. I'm just going to make this one the double bond. That means that we've used 2, 4, 6, 8 of my 24. And that means that this sulfur now has 8 around it. Oxygen, this oxygen only needs 4. And so now I've used 2, 4, 6, 8, 10, 12 of my 24. And the other 12 get separated out, 6 and 6. Now there's going to be something else that is used to describe this dot diagram. This is not the end. We're going to talk about something called resonance with this one. But the other thing I want to point out is that the shape that I use to draw it on paper, well, on my tablet, is not the same shape that it actually is. This sulfur has 1, 2, 3 atoms bonded and no lone pairs. So that means that this structure is actually trigonal planar 120-degree bond angles. So these oxygens are actually pointed up a little bit, and it's actually, if I was going to redraw it, it's actually more like this. With 120-degree bond angles, which means that it has no net dipole moment. I'm actually going to stop there and maybe do the next video with the next question. This was number 3 from your notes packet if you have me. I'll do number 4 in a separate video.